Okay, so I just wanted to do a quick check-in with you guys on numbers 43, 44, and 45. Um, so on number 43, it tells us that we're rotating 240 degrees around the origin, starting at point G. So I'm going to start at point G. And remember we talked about yesterday, since this is a hexagon with 6 sides, we know there's 360 degrees in here. So if I take 360 and split it up into 6 parts, each of these like triangles, if you will, here, right? So here's a triangle, IOH, and here's a triangle HOF, right? Each of those kind of central angles there is going to be 60 degrees, which means with these pieces that are bisecting that angle or cutting that triangle in half, splits these into 30-degree kind of sections as we go around the hexagon. So 240, if we think about how many 30 groups of 30 are in 240, we know that there's going to be 8 groups of 30 and 240, or you could even just go over here and count 30, 60, 90, right, until you get all the way around to 240. So I'm just going to count 8 groups around. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, and that ends me up at A. I believe my answer key said I yesterday, and so I'm not sure. Maybe I just got sidetracked and counted too far. So A should be our answer on that one. On number 44, I had I in my answer key yesterday, which was correct, but I think because all of these ones were origin, and as a teacher, we just kind of get in our mindset of what we're talking about. I was thinking about the origin. Didn't pay attention when I was talking to you guys that this is actually rotating around point H. So if we're trying to figure out, okay, I'm going to take point F and I'm supposed to be rotating it counterclockwise somehow around point H. Well, H already has these 2 lines here, right? So it'd be useful if we could kind of figure out what's going on in these angles here. Well, if you think about these triangles that are being formed by the hexagon here, if this is a 60-degree angle here, and these are kind of like the radii, right? The radius pieces of our hexagon going from the center to the outside. If this is a regular hexagon, then that means that these 2 pieces are congruent. Well, if those are congruent, it's an isosceles triangle. It means our base angles are congruent, blah, 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 blah. Maybe I should put some markings in here. So I'm saying that both of these green segments here, I know that's kind of hard to tell there, right? But this segment and this segment are congruent. It's a little bit off, which means if I split the rest of my triangles up, I should have kind of a 60-degree angle here and a 60-degree angle here. So we actually do end up with an equilateral triangle, right? So that is telling me that this segment is congruent to those other 3. So the reason that's important is, well, now I have 2 60-degree angles here. So this whole angle here is actually 120 degrees. So if my goal is to be rotating H 120 degrees, or sorry, rotating F around H, well, I actually just have a 120-degree angle right here. So I could just go 120 degrees, and there we go. We end up at point I. Okay, so we're still going counterclockwise in that sort of left direction as we go around. And then on number 45, where we're trying to rotate point M around L, let me go ahead and just erase all this other stuff because it's really overwhelming to look at. But if we're trying to rotate M around point L, 270 degrees, the first thing I think is, because see how we kind of have a square going on here? I'm going to think, okay, we're probably going in groups of like 90-degree, right? So 90 times 3 gives me 270. So I was thinking, okay, maybe I'm, if I'm trying to go counterclockwise, it's pretty tricky around point L because all these angles are sort of like funky. But what I thought as I was going around was, well, what do I know, right? Well, I know that this is a 90-degree angle right here because we have a square on the inside, and it tells us, I think it tells us that we have, let's see, that they're regular shapes that are in here. Oh yeah, it tells us we have a regular quadrilateral up at the top there. So I know that this is a right angle. Well, if that's a 90-degree angle, what that tells me about the sort of this outside piece here, right? If I want to take M and rotate it counterclockwise around L, well, I just have to subtract 90 degrees basically. And if I have 360, right, if I want to take M all the way around, but I'm not quite going all the way around, I'm only going all the way around but minus 90, that actually leaves me with 270 degrees sort of on the exterior of L. And so that's kind of how I figured this one out. I got K for this one, was just that I'm starting at M and I'm going almost all the way around, but not the 90 degrees, which gives me 270. So I'm just going all the way around there, and we end up at K. Hope that helps. Please get your homework turned in, hopefully by tomorrow, and I'll try to get it graded either tomorrow or on Monday. Thanks.